Hello and welcome to this lecture on Introduction to R for undergraduates and how to get started in it. What we're going to talk about today is what R is as a platform. I will introduce you to some basic commands in R and then I will release you to go work on it. I anticipate that I will probably go too fast at times, hence the reason that you have a pause button. So please, when I tell you to go try something in R, make sure that you actually try it. You need just to pause the video and then come back to it. This lecture, although I'm consistently told that I'm becoming out of date even as I speak, but this lecture is based on Harry Potter material, or the Harry Potter movies, as at least a way to try to bridge the gap about how to understand it. So what is R? Right? So what are we dealing with when I say this symbol, this single letter? R is a computer language that's going to allow you to program the various things within a syntax. So you're going to be able to tell the computer exactly what you want to do, but you're not going to be driving it by selecting buttons and then clicking down on different drop-down menus, but actually by writing to the computer, by saying, this I want you to do to this, which means that you'll have far more power, you'll have far more control, but it will also be more difficult at the start because you're learning a new language. The advantage of R is that it's what we call open source, which means that it's available for free at any time. You can go on and download R no matter where you are in the world, as long as you have an internet connection. You'll never be charged for that. And that has a remarkable flexibility in that you could send it to a collaborator and know that they could do exactly what you're about to do in the program. It's also very useful because you can generate figures in it. And if you generate figures in it, you can use that open source format again. You can send your data to your collaborator and actually have them generate the same figure you are. You don't need to send them a copy of the figure necessarily, but you can send them the data that generates the figure. There are other programs out there that do some of these things. There are programs like SAS or SPSS. These are statistical programs that can also generate figures. These programs tend to be driven by either drop-down menus in the case of SPSS or by syntax in the case of SAS. These programs, however, have some limitations that R does not. Now, they do have some advantages over R in some ways, but R is a cutting-edge program and is widely adopted. Again, so it is very, very useful in that sense. And then finally, R is open source, so no matter what happens, you don't have to pay for it. And this is a huge advantage because SAS and SPSS are extremely expensive. Think on the order of thousands of dollars per user. So what is SAS and SPSS? This will make more sense. But if you remember Harry Potter, SAS and SPSS users, you can think of them as more like muggles. They may know about the magic of things like R, but they themselves cannot use it. SAS and SPSS users have very limited ability to change the environment that they work in. They often rely on the company themselves to produce the algorithms that they're going to use. So the writing within the program is more limited, and so they can do less flexible things in it. The problem with this is not necessarily that every user is what we call a power user and would use every function to its maximum. But if there's a new thing a new kid on the block or a new function that is being produced, I simply can't expect it to be in my version of SAS or SPSS. It takes at least a year for it to be incorporated, right? So if a new statistical technique comes out, I have to wait at least a year for the company to catch up and drop it into SAS and SPSS. And that means that the people that are making the program have to think it's worth their time. Okay, so if it's a relatively rare process that very few people will use, then you can anticipate that very limited chance that will appear rapidly in SAS or SPSS. And as I already alluded to, SAS and SPSS are not cheap. You're going to easily pay hundreds of dollars for the program, and if you're buying it at a license for a site, you're paying thousands upon thousands of dollars to have access to that program. That program will also expire. One of my most hated features about SAS was the constant warnings that the product was going to expire, which began 180 days before the product expired. So every time I ran code, I would get a little warning, by the way, your product will expire. And that continued for 180 days. Since we were on an annual license, that means that more than half the time my code was filled with error messages from SAS. So why doesn't everyone just use R then? Okay, so R is actually fairly difficult to get into, so I'm not going to lie to you and say, oh, this will be easy, this will be the easiest thing you've ever done. R is difficult to get into. It has a steep learning curve, right? And here is a funny example of that. SAS SPSS, another program, Minitab, have very gentle learning curves, relatively speaking. However, they're capped at a much lower level in that they cannot do the functionality that things like R can. The advantage again to R is that if you can get over that learning curve, you can do really amazing stuff. So again, the advantages to R here. It's fast, it's free, it's state-of-the-art. It can produce excellent figures. It has other programs that can piggyback onto it, and has an extremely active community, which means if you have an issue, somebody else has had it. Disadvantages for R. It has a steep learning curve. It is easy to make mistakes as a result and not know what's going on. And also not know that you made the mistake. And it is very different from programs many undergraduates are familiar with. However, I think the differences, although they are large, are actually useful because they're going to require you to think about your data in a way that is more efficient and more intelligent. So here's a good quote. I like it. Using R is a bit akin to smoking. Its beginning is difficult and you may get headaches, but after a short time, something down there will become pleasurable, maybe even addictive, and then you'll get good at it. Just like smoking, practice makes perfect. I'm not advocating smoking, but I am telling you it's the same way with R. You are not going to enjoy it necessarily the first time you do it. You may not enjoy it the first few times you do it. But the more you expose yourself to it, the more you continue to come back to it, the more you will see the power of the tool, and the more it will be attractive to you to use. In R, you're going to get errors. You're going to get errors a lot. Errors are a good thing. I don't want you to think that because you are generating errors, you are doing something wrong. When I run R scripts, I generate errors constantly. I need it only to run correctly once. I can generate errors on my script for days at a time, but that one time that it operates is it. I'm done. So errors are important. They're going to tell you that your program is not running correctly. They are going to tell you what's wrong with it, and they're going to guide you in a way to make you understand it. In some cases, errors may even give you a warning that your statistical approach is not appropriate, that you're not doing the right thing, you're not analyzing the data correctly, and that you need to go back and sit down and think, what am I actually testing? What is the stat I'm actually using? So, unlike a lot of situations where we think of errors as failures, I want you to think of errors as an optimal way to learn about the material. It will be difficult, but they will be useful. The other thing is, don't worry about errors in the sense that don't worry that they're going to appear, okay? Relax. When you have a question for me, ask it. When you feel lost, which is completely normal, feel free to say, I feel completely lost. Did I miss something? You can ask that to other students. You can ask it to me. It is important to understand that everyone is going to struggle with this when they start. When you interact with me, you're going to see someone who has used R for years. Your interpretation of that may be, I will be this good, or I must be this good when I start. There's no way that's going to happen. Every time I get into R, I learn a little bit more, I learn a little bit about it. And it's that way in which I have gotten good at it, but it has taken years. The first few years I used R, I was not very efficient. However, the fact that I kept applying it to the problems I had at hand meant that eventually I did become very efficient at it, and the tool became very useful to me. This is a good reminder of what you can expect to see. When you start out, your ability will be relatively low, but the effort you've put out is fairly limited, and you'll pick up a few obvious things that are in the program. That's wonderful. You may be able to find tutorials after that that expand your ability. These will be a low effort environment, right? You're not putting out very much effort. At some point, your ability will increase because you can begin to understand the documentation, the actual help files that are associated with this program, and you can read and interpret exactly what the programmer meant. It is at this point that you will cross a boundary and you will enter the world of not documented problems, problems that are unique and specific for you. And you will put out enormous amounts of effort and your ability will not increase very much. And you will think, I'm at a dead end. This is useless. I should give up. However, If you can get over that, what you will find is this thing up here, strategic experience. You will rapidly be able to adapt different environments to work for you with very little effort. Okay, so you will do a huge amount of ability growing. These are power users or very advanced users of a program. This is where you can reach, but I want you to understand that it's a slow process and it is difficult at times. And it is infuriating when you feel like you're standing still and not learning, especially when you feel like a deadline is coming up. But be patient and work at it, and you will be rewarded by being very efficient at the program. This used to be the case. R had a help website that was the listserv for R. The listserv for R was always a bit hairy. It initially included mostly members that had actually programmed the actual program itself, and that when they would request questions, they would say sort of surly things like, well, go read my help files. I wrote big, long help files. And it's true, they did write big, long help files. The problem was they were so advanced that they didn't even realize how convoluted the help files felt to new members. This is largely not the case anymore. There are so many different levels of users in R, from people that have simply picked up R for the first time and have opened it once, to people that have probably opened it multiple times or may run multiple instances of it on their computer every single day of the week. If you are looking for help with R, my two recommendations then are pretty obvious. One is Stack Overflow, which you will find you will end up at many, many times. It's a place where people ask questions and they can be responded to. Answers can be voted on so that generally the best answers rise to the top. But check all the answers if you're struggling with something. Remember, one answer on Stack Overflow is not necessarily the solution, although it can be helpful. The other thing you should be looking at is Google or some search engine. Do not forget, even if someone else is teaching you R, the best teacher you will ever have is you. So go to Google, put in your error code, figure out what's going on, start to ask questions there and see if you can figure out the help files. Far and away the most useful thing for you will be to comfortable using Google to ask questions with R. So let's dig in then. So go ahead right now and pause the video and go get R. My recommendation to you is to search it in Google. If you have R, or you've downloaded R at this point, what you should be able to do is open a program like this. This is the console or command window. Take a look at it. This is a very old version. You can see that up at the top. This is 2.14.2 from 2012. The reason that I don't have a more updated screenshot is I don't open R this way. You will never need to open R this way. So close this by hitting the X at the top right of your screen, or if you're on a Mac, the top left, and bring it down. You'll never need to look at this again. What you should do instead is go online and download the program RStudio. When you download RStudio, you should install it like any other program, and then you should open RStudio. RStudio is a program that runs R in it, and then it will also help you to keep track of your code, keep track of things that you've brought in, and will provide you views of both the figures you generate and the help files you'll need. RStudio is a remarkably useful program. It's separate from R, but it is also free. Very, very functional and useful for us. RStudio is the only way you should be entering R, and you never need to open R separately. Every time you click to open up RStudio, RStudio will open itself, and then it will open up R inside of it. So what are the parts of RStudio? Your window will change. It may not look exactly like this, and I'll show you why that is the case in just a moment. But let me show you what's inside RStudio. Up here in the top left box is where your code will go. This is where you can write things. Down here is where R is located. When you execute code, R will be sent the code from your code box, and it will go down here and R will produce output. This is one of the most useful features about RStudio. RStudio keeps track of everything that you put into R. So anytime you incorporate data, files, material into R, RStudio will keep a list of that for you so you know what's there. It will also subdivide the list so you can actually look inside the object without opening it directly in R. And these are a wonderfully useful place for you. And down here in the right, it'll tell you what directory you're in, so where the files you're picking up are from, what figures you've generated, or where your figures will be located, packages, which I haven't talked about, which will be extremely useful to you and you've actually already loaded even though you don't know it when you loaded R, and the help file, which is again one of the things that you will need to rely on frequently. You will notice here in this particular environment that I have loaded that I actually have a help file already open, and then I had no code in. This is very normal. I need to search the help files all the time, so you will too. Let's take a look then at our RStudio that I have open. In this RStudio, my screen is black. If you've just opened up an RStudio, you probably don't have this particular view to it. You can also notice that I've resized things within RStudio. To do that, simply grab the button and pull it around, and you can pull it. You can make it wider, you can make it taller, you can make sections smaller. You can actually delete whole windows, although I wouldn't recommend that. Generally, as you start, the four windows will be roughly similar in size, although the code and the R window usually are a little bit larger. To change your color and appearance, which is what I prefer to do so I can actually read things more easily, go up to Tools, go to Global Options, go down to the paint can which says Appearances, and then you'll notice there's a ton of options in here. If you like the one you have, feel free to keep it. But if you want to try one, try clicking on any of these and seeing what they look like. Because I tend to look at R a lot, I usually like darker screens so that it doesn't strain my eyes. But if you like the lighter backgrounds, feel free to use those as well. There's lots of options. My recommendation to you is to use one that color codes different things. Although these don't matter to you right now, the different colors here have different meanings. I'm not going to select any, but you can. You should select Apply or OK and then close the options. When you come back out to RStudio, what you'll find is you can type anything you want up here. For instance, I am typing up here. That will appear, but it will not have been sent to R. When I'm ready to send things to R, I will hit this button up here which says Run, or you can hit Control and Enter at the same time and it will send this line of the code to R. Keep in mind, R is not going to understand what this means. I am typing up here. That's not going to mean anything to R, and it'll come back with a confused error message if you do that. I do want to show you some more complicated code. At some point, you'll be able to develop code like this. This seems sort of staggeringly difficult for you right now, but it will not be in the future, and you can read this at some point. This is a different language, but you will be able to read it if you spend time inside R. Let's return again to our presentation. So here is a series of steps that I would recommend you try. I would recommend that you try doing these in order, but I recommend also that you try pausing after each one and seeing what happens. So in the R interface, so that is the screen at the bottom left, go ahead and hit 2 plus 2 and then hit Enter. I would also recommend you type in 2 plus 2 in your code window and then hit Enter up there and see if it's different. Try in your R interface multiplying a number by 3 and see if you can figure out how to raise 2 to the power of 4. Finally, I would spend some time looking around and figuring out how would you take the square root of 2 in R. Again, Google is your friend. Go ahead and start to search. If you did the things in the previous slide, you should feel comfortable using R as a basic calculator. Basic calculating functions are fine. They're useful. You will use them again in the future, but this is certainly not R's main priority or the main power that you're going to get from R. Try log 10 here and see what happens. Do that inside the R command. You could also write it in your code window now and then execute it by hitting Control Enter. What would happen if you added a bunch of spaces between, say, the parentheses and the 1? Why didn't you try it in C? The other thing I would recommend you try is put a question mark before the log command. See what happens in RStudio. What else can R do? Well, R can do lots of stuff like create figures. So look in the background of this slide. This is something created inside R. It looks very attractive, right? We can get you to this level. But what I want you to do first is type in demo graphics and execute that. And I'd also like you to try that by putting a hashtag or pound sign, really, before the demo button and see what happens. If you have tried using the hashtag or the pound sign, what you should notice is that that particular thing makes R accept the words that follow it as simply to be reported. So you can put notes to yourself. So if you write a lot of code and then you put a pound or a hashtag, you can mark up your code. You can tell yourself what you were doing. You can tell yourself what particular sections do. You can tell yourself what you expect to happen. That's called annotating your code. I would recommend that you get into the practice of annotating all the time. It's very helpful to annotate, especially if you have a problem. You may even put a line in that says code works up till here, right? And then go seek out more help. Graphs in R can look really pretty, but they can also be kind of tough to generate. Although there are a number of very good programs, the one that I'm showing you in the back here is a program ggplot within R that can help you develop graphs more rapidly and produce very high quality graphs with a little more limited input. So why don't we just use Excel then? Why am I giving you this additional layer of difficulty? Well, Excel is a really poor excuse for a graphics program. It doesn't matter if it's a new version or an old, it still uses the same thing, which is the chart wizard. The chart wizard is an old sort of internal production of graphs in Excel. It was never very good. It remains pretty poor. It's gotten slightly better. It's only very recently that even some very primitive statistical graphs that I would consider necessary, like histograms, have been added to Excel, and they're not very good. In addition, Excel is a really bad way to store data. There's a number of things that Excel allows you to do that cause data to be stored inappropriately and that should not be added to data. It is also really encouraging of using inappropriate things like color or size of text to provide information. You should not be using those kind of things to provide information in Excel. If you send that data file to anyone else, they'll have no idea what those things mean. Here's a great example of a terrible graph you can make in Excel, just to convince you that this program is fairly out of date, or has always been out of date for graphics. It is impossible, for instance, to see the back row. It is impossible in this case to see what heights these various bars are actually at. This 3D nonsense is what Excel loves to push, and it is really, really, really difficult to know what is it actually telling you. Jan, Feb, March, April is assuming months of what year. It's not doing a good job of aligning any of this information, and it's really finicky, right? If you make mistakes, you actually have to go in there by hand and move everything with an individual click and then select something different. In R, once you have the graph you want, you will always have that code. It will be simply a matter of incorporating the code that you want, or the data you want, into the code that you already have. You won't have to go in and finagle every single graph. So briefly, wrapping it all up, R is difficult but is worth your time. It will require you to work at it to get good, but you will find it rewarding if you do. You will also find that this program becomes more powerful as you invest in it. So the upper ceiling for R is very high. The more you invest in a program, the more that this program will reward you with the power and flexibility that you need to use it. The other thing that I really like about R is that it makes you think efficiently about your data, and it makes you think about how to generate professional figures. And the people who use it and the community that is in it is very concerned with these things. So you can anticipate you will produce the kind of materials that you need to get things like jobs in the future. And with that, what I will do is have you turn to your lab notebook now and begin the exercise.